Okay, full. Okay, alright.
Okay. Okay. Sekali lagi Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh.
Assalamualaikum.
Okay. Inshallah today we will share my experience about particle swarm optimization. Basically, what is the particle swarm optimization, or we can call it as a PSO algorithm. So next, I will discuss where we can apply this algorithm. Okay, basically, my name is Muhammad Noor bin Abdullah. I am from Faculty of Electrical and Electronic Engineering, okay, UTHM. Okay, so in this short course, inshallah, I will discuss in brief about the concept of optimization. Basically, what is optimization? And next, I will discuss about what is particle swarm optimization. Okay, what is PSO? Commonly, we call it a PSO. PSO basically is one of the, we can say, a famous algorithm. Okay, in order to solve the optimization problem in many applications, either in electrical engineering, in mechanical engineering, in computer science, and so on. So next, I will discuss the working principle of PSO, or how it's worked, the behavior, the characteristic of the PSO, and then the last one, inshallah, I will discuss in brief the application of PSO to solve the real problem. To solve the real problem, especially in my field, which is in power system application. Okay. Okay. First of all, we have, when we're talking about optimization, basically why we need to optimize. Okay, why we need to optimize our system, basically. Okay, why we need optimization algorithm. Okay, of course, we have a limited resources. Okay, for example, we try to reduce the operation cost of the system. Okay, in order to increase, in order to enhance our revenue or profit of the system, for example. Okay, we try to minimize. So that's become the optimization problem, because our purpose actually is, let's say, to minimize the cost or to maximize the profit or revenue. Okay, number two, okay, maybe we try to minimize the cost and emission, let's say, in power system. In power system, we have a generation cost. We generate electrical system with the thermal generator, for example. Of course, we have emission. So the question is how to minimize the cost as well as the emission. That's why in this situation, we need optimization algorithm. Okay, next, maybe you are very familiar with the maps. Okay, maybe with Google Maps and so on. So if you realize in the maps, we can choose whether we try to minimize the cost or we try to minimize the distance. Okay, that's one of the example of the optimization problem in the, we can say, in the real world. Maybe in the electronic or in the data science and so on, they need the data optimization. Okay, they need the data optimization and so on. This is the example why we need the optimization algorithm. Okay. Okay, basically, this is the example in the power system, because my background actually is power system. Let's say in the system, in the electrical power system, okay, we have so many generators. Maybe you can try to imagine in Malaysia, we have maybe more than 100 generators, okay, with different cost characteristic of each generator. For example, we have a coal, we have a natural gas, we have a biomass, we have a PV, okay, hydro, and so on. So every generator, they have their own cost characteristic. So the question is, in order to deliver power from the generation side to the customer, to our residential, to our university, to our building, or to our factory, and so on, so we need to minimize the cost. Okay, so maybe the system operator need to minimize the operation cost. Okay, of course, they need the optimization algorithm. Maybe they need to minimize the emission of the power generator. Okay, from the generation, from the power generation, of course, we have a CO2 emission, for example. So the question is how to minimize the harmful emission from the generators. So we need to minimize, of course, we need optimization algorithms. Of course, we need to transmit power from the generator to the customer, to the residential. We have a transmission. Of course, we have losses. The question is how to minimize the losses. This is the real problem in my field, in power system application. I believe you have your own problem in your field regarding the optimization problem. Maybe you try to minimize something, cost, traveling path, and so on. Okay, so let me share we can say my latest publication that related to particle swarm optimization. I believe particle swarm optimization is one of the we can say one of the good algorithm to optimize our system. In this case, this is in 2020, the latest publication. We apply this particle swarm optimization to determine the light optimal sensor placement. To determine the optimal light sensor placement in the commercial building in order to improve the, we can say, in order to minimize the energy performance and maximize the visual comfort. This is the real problem, and then we can apply the particle swarm optimization. This is, for example. So let me share about what is optimization. Basically, what is optimization? Maybe before we go further to discuss about PSO, we need to understand, we need to review the concept of optimization. Basically, optimization basically is the searching process. Searching process for obtaining the best solution. The searching process to obtain the best solution, whether we want to minimize the system or we want to maximize the system. Based on the combination parameters. Based on the combination several parameters, and then we need to satisfy the constraint. So in the optimization, we have the three main important parts. First of all, our objective. In the optimization, we must have an objective, whether we want to minimize or we want to maximize, and then we have our parameters. What's parameter that we want to minimize, for example, and then of course that parameter, they have their own constraint. So I will discuss in details in the next slide. Look at to the example of the optimization solution. Basically, what we have to know in the optimization solution, we have let's say we try to minimize our problem. Of course, in the minimization process, we have two possible solution. Basically, we have two possible solution. Number one, basically in the complex optimization problem, they have they have maybe some local minima. This is the example of the local minima. The global minima that we try to search by using optimization algorithm is basically we call it global minima. This is we can say the real minimum point that we want to search by using heuristic optimization algorithms. That's the main objective that we try to implement. We can say the robust algorithm to determine the global minimum solution. Sometimes our algorithm, our optimization method, just trap or just obtain the local minima. That's the issue in the optimization problem. So before we apply the optimization algorithm, any optimization algorithm, this is the basic optimization problem that we need to understand. Maybe I believe some of you may be familiar with the optimization problem, optimization method, and so on. So I try to review. Okay, number one, we need to clearly define our objective function. What is our objective function? For example, this objective can be a single objective. For example, to minimize the to minimize the traveling path, okay, of the robot, maybe, or to minimize the emission, to minimize the losses, and so on. Okay, our objective can be single or multi-objective. Multi-objective means combination of two or more objectives. Maybe we try to minimize traveling path and cost of the system. For example, we have two objectives. Okay, we have to clearly define. So mathematically, we can write in this form. Okay, we try to minimize this objective function. So this objective function can be a single and combination of several objectives. Okay, and then number two, we have to know what is the variables that related to the objective function. Okay, let's say you try to minimize the cost of the system. What is the variable that influence the cost of the system? For example, let's say power output. Power output of the generator can influence the cost of the generator. That's power output can be our variable. Of course, that power output, for example, that's variable have their own constraint. Okay, have their own constraint. So in the optimization problem, we have to clearly define or clearly understand what is our constraint. Okay, basically our constraint is related to our variables. Okay, for example, we have equality constraint. Okay, or we can have inequality constraint or combination of equality and equality constraint. This is the general concept of the optimization problem. Okay, this is the overview. Okay, this is look at to the example, to the simple example, okay, of the optimization problem. This is a simple mathematical optimization problem. Okay, this is not the real one. Okay, let's say we try to minimize the function of fx. Okay, this fx, let's say we have an equation. We already formulate our problem into mathematical function. Let's say we have this function. Okay, this function we have variables. In this case, we have x1 and x2. So what we can say that in this problem we have two variable. Okay, which means we have x1 and x2. Okay, this variable, of course, they have their own limits. They have their own constraint. Okay, for example, in this case we have inequality constraint, which means that our value of x1 and x2 within from 0 to 10. That's the limit of the variables. That's the parameter that we have to clearly define, clearly understand before we apply the optimization algorithms. Okay, so we have an objective function, and then in this case we have two variables. But in the real application, I'm not sure, maybe in your application, I think you have more than two. Maybe you have 10 variables, okay, in order to optimize your system. Maybe in my personal experience, maybe in Power Dispatch, sometimes I need to solve maybe more than 100 variables. Okay, that problem cannot be solved easily by the traditional method, such as linear programming, quadratic programming, and so on. So we need heuristic algorithm. We need meta heuristic algorithm like PSO, like artificial bee colony algorithm, like Firefly algorithms, ants colony, and so on. Okay, this is the concept. This is the overview. This is the fundamental, the optimization problem. Okay, so what is the task of the optimization algorithm? So optimization algorithm will search the possible value of the variables. We search the possible value of the variable within the limit. Okay, within the limit in order to minimize the objective function and satisfy all the considered constraints. Okay, that's the main task of the optimization problem. Okay, so this is overview. This is overview about optimization method. maybe I think we have a guest from computer science. I think they are very familiar with this topic. We have our guest from the Faculty of Electrical Engineering, maybe in the field of computer engineering, so they are very familiar. But let me share with you the overview of the optimization method. Basically, we have a conventional method. Okay, this is a very common method that every engineering student or computer science student familiar with this algorithms. For example, we have a linear programming, we have dynamic programming, quadratic programming, lambda iteration gradients method, Newton-Raphson, and so on. Okay, this conventional algorithm basically depending to the derivative of the derivative method, right, in order to optimize the system, okay, by using a mathematical approach. Okay, we can say the main weaknesses of conventional method basically is commonly fail to solve the problem with multiple local minima. But because in many engineering application we have a multiple local minima. Okay, sometimes this algorithm will start or will trap at the local minima because our purpose actually is to determine the global minima. Okay, number two, okay, we have a meta heuristic. Okay, for example, we have a particle swarm optimization is one of the meta heuristic algorithm. We have a genetic algorithm. Okay, we have maybe firefly algorithm, ants colony algorithm. We have so many algorithms that can be categorized under heuristic algorithm. Basically, this algorithm actually is free derivative. There is no derivative method that apply in this algorithm because it works based on the population-based algorithm. Okay, population-based algorithm, and that thus it's suitable to solve any types of objective function, whether it's linear, whether it's convex or non-convex problem. Okay, mostly, okay, this algorithm, this heuristic algorithm basically is inspired by natural phenomena. Okay, if I'm not mistaken, we have UKM, one of the PhD candidate in UKM introduced lightning search algorithm. Okay, based on the behavior of lightning. Okay, thunderstorm. Okay, they try to formulate that situation, that natural phenomena into optimization algorithm. They call it a lightning search algorithm. Okay, if I'm not mistaken, currently we have, if I'm not mistaken, coronavirus algorithm, if I'm not mistaken, produced, I'm not sure, maybe from the UTHM, from the computer science, if I'm not mistaken. I just read that paper. They produce coronavirus, if I'm not mistaken, coronavirus optimization algorithm based on the coronavirus behavior. Okay, okay. But the existing algorithm, we have a genetic algorithm according to the genetic behavior. We have a particle swarm according to the fish schooling and bird flocking, for example. We have a firefly. Firefly is kunang-kunang. Okay, based on that firefly, scientists try to develop the optimization algorithm. How that firefly move to the light, for example. We have ants colony according to the ants behavior. And then we have a bee colony, artificial bee, and so on. So many heuristic algorithm basically is inspired by natural phenomena, human behavior, and animal behavior. And then the third category of the optimization method we can call a hybrid. Hybrid means combination of both meta heuristic and conventional method, or combination two or more algorithm. Okay, for the main purpose actually is to improve the weaknesses of the single algorithm. This is the available optimization method in the literature. Okay, so in this short course we discuss about particle swarm optimization. Okay, the fundamental of particle swarm optimization. Okay, this is the fundamental or concept of particle swarm optimization, which is developed by J. Kennedy and his friend in 1995. Okay, dah lama in 1995. Okay, this algorithm basically is inspired by fish schooling and bird flocking. Okay, based on the bird movement to find the food, for example. Okay, these scientists try to formulate the behavior of bird flocking into the mathematical equation. Okay, basically this particle swarm optimization, okay, works based on the population, based on the group of individual to find the optimum solution. Okay, according to the behavior of the bird, they try to fly and move to the to find the food. Okay, that food actually is optimum solution for the bird. Okay, for example. Okay, so these scientists try to formulate the behavior of bird into the mathematical function. Okay, basically, an individual in the swarm, okay, individual or particle in the swarm approach to the optimum through the previous experiences. Okay, to the previous experiences. Okay, present velocity and experience of its neighbor. Okay, because we have a group of birds. Okay, we have one bird, so they try to learn from its own experience, and they try to follow the best bird in the group. Okay, so look at to the mathematical formulation of particle swarm optimization. Okay, this is the principle of particle swarm optimization. Okay, PSO use a number of agents or particles. We call it particles. In terms of bird, we have a number of birds. Okay, but in the PSO, in the mathematical formulation, they call it a particle that constitute a swarm moving around in the search space looking for the best solution. Okay, this particle, okay, actually these particles represent the problem variable. Okay, in the real optimization problem, this particle basically is represent the problem variables. Okay, for example, power output. Okay, in the optimization problem. Okay, each particle in the search space try to adjust its flying. Okay, let's say this is a bird, we call it a particle. They try to move from one position to another position. So how to move? They try to learn from the own flying experience. Okay, own flying experience from the previous experience. That one we call it a personal best experience. Okay, and then they try to learn from the experience of other particles, or in this case from other birds. Okay, we call it global best position. These two main parameters will help the particle to move from one position to another position in order to find the optimal solution. That's the overview or principle of the PSO. Okay, basically the movement of the particles towards promising area to get the global solution. Of course, they try to find the global solution. So each particle keeps track to its best solution. We call it personal best position, and then the best value in the group. Okay, because we know that bird we try to fly in the group, so they try to learn from the best particle in the group. We call it the global best of the swarm. Okay, this is the two main parameter. Okay, so each particle adjusts its traveling speed. Of course, from the one position to another position, they need a speed. We call it a velocity. Okay, they try to adjust its traveling speed dynamically, corresponding to the flying experience. Okay, according to the experience of P best and G best. Okay, each particle flying or moving according to its current position, its current velocity, the distance between its current position and P best, and the distance between its current position and the G best. Okay, this is the illustration behavior of the PSO. But the most important thing actually is this one. Okay, the updating equation of the PSO. Okay, we try to discuss more on the mathematical equation. Let's say we have one bird, how to move from one position to another position, they need a velocity. Okay, so the scientists try to formulate this, the velocity of the particle basically is according to this equation. According to this equation, for example, this is the original position of the particle. They try to move from this position to another position, they need a velocity. Okay, this velocity basically influenced by the global best candidate solution. We call it a G-best, this one. And then it also influenced by personal, we call it a P-best. Okay, and then influenced by its own best solution. Okay, and then this current position will move to the next position by using this equation. Okay, this is the next position of the, let's say, particle. This is the current position of the particle. So it moves according to the velocity. Okay, this velocity, okay, basically influenced by the personal best position and then global best position. In terms of mathematical equation, this is the mathematical equation of velocity, and then this one actually is the updated position of the particle. Okay, this is the details. Okay. Okay, basically in PSO we have, this is the equation of velocity for PSO. Basically we have inertia. Okay, we have WV. Okay, W. This W we call it inertial weight factor. Okay, this parameter actually need to tune before we use PSO. We need to tune. We need to set this parameter. We need to test. We need to do the experiment to set the proper value of W. Okay, basically, according to the literature, according to my also my personal experience, this W actually the best range of this weight factor basically between 0.9 to 0.4. Okay, decreasing according to the iteration number. Okay, the main purpose of this weight actually is to increase the rate of convergence speed of PSO. Okay, convergence speed of PSO. Okay, this is the personal influence. Okay, personal best. Okay, personal influence. Okay, the main purpose of this parameter actually to improve the individual position and makes the particle return to a previous position if that previous position is better than current position. It's better than current position. Okay, this one we call it a social influence of the PSO parameter to make the particle follows the best neighbor position. Okay, we have a group of bird, for example. Of course, we have the leader, the best one. Okay, they try to follow the best one. This according to this equation. Okay, C1 and C2 actually is coefficient. Is coefficient. We have we need to define this coefficient. This one we call it acceleration coefficient. So I will share with you how to set the acceleration coefficient for PSO. Okay, and RAND basically is random number. Okay, because heuristic algorithm is works based on the random number, but guided by certain behavior. In this case, guided by according to the particle swarm. Okay, I think okay. This is the pseudocode and flowchart of PSO. How to implement PSO. Okay, so in this slide, we'll discuss how to implement PSO. Okay, so first of all, this is the pseudocode of PSO. This is the flowchart of PSO. Basically, look at the flowchart. Okay, we need to initialize the PSO parameters. In this case, we have initial weight factor. We have acceleration coefficient, which is C1 and C2 in the previous slide. In this slide, we have a C1 and C2 we need to initialize, as well as this initial weight factor. We need to initialize. We need to determine this value for W, C1, and C2. That's the meaning of initialized parameters. Okay, the question is, what is the best parameter, okay, to set for the PSO algorithm? Okay, and then of course we need to evaluate the fitness function. Okay, our fitness function basically is our objective function. Basically, is our objective function, and then we need to update the personal best and global best, and then we need to update the velocity. This velocity basically according to this formula. And then we need to update the position of each particle according to this formula. And then basically optimization algorithm actually works according to the works iteratively. Okay, iteration number 1, iteration number 2, iteration number 3, and they try to repeat, update, and update until the termination criteria is met. Okay, is satisfied. For example, maybe your termination criteria may be maximum iteration, convergence, and so on. Okay, okay, this is the iterative process. Okay, look at the pseudocode. Okay, this is the initialization. Okay, for iteration 1, let's say J is the number of iteration. Okay, iteration 1. Okay, and then because we have a PSO. So in this case, PSO works based on the population size. We have a number of particles, okay, in the population size. For every particle, we need to evaluate the fitness function, and then select the p-best for the particle number 1. Okay, let's say we have a 20 number of particles. We need to repeat particle number 1, particle number 2, number 3, and up to 20, for example. And then we determine the global best solution. And then again, we repeat for each particle to update the velocity and position. Okay, this is the pseudocode of the PSO algorithm. From this pseudocode, we can code in our programming software, for example, in the MATLAB and other programming software. Okay. Okay. PSO parameter. Of course, before we use the PSO, we need to set the parameter. In PSO, we have several important parameters. Okay, number 1, we call it number of particle or number of population size. Commonly in PSO, we can use population size 10, 20, 30, 40, or 50. It depends to the complexity of the problem. If we don't know the complexity of the problem, we can try from 10. If we feel our solution is not good enough, so we can increase the number of population, let's say up to 50. This one is the testing process or experiment process. Okay, until we believe that our solution is better than before. So we can set that number of population as a population size in the optimization algorithm. Okay, in the PSO we have constant C1 and C2. Okay, this C1 basically is important for the personal best value. Okay, for the C2 is important for the neighbor best value. Okay, basically based on the previous research, okay, reported in the literature, the best value for C1 actually according to this equation, which is C1 plus C2 should be equal to 4. Okay, based on the previous experience that reported in the literature. Okay, this is the empirical value lah. Okay, but it's not fixed. It's depend. You can try and error in this case. This is the characteristic of the heuristic algorithm. We have to tune the parameter. Okay, we have to tune the initialization parameter of that algorithm. Similarly to other algorithm, we need to tune the parameter. Okay, I will discuss in brief what is the effect of this parameter. Okay, this parameter will affect to the velocity equation that I have shown before. If the velocity is too low, the algorithm become too slow. Okay, if the velocity is too high, the value of velocity is high, the algorithm is too unstable. So we need to do experiment to ensure that we can satisfy the convergence, and then we can determine the global solution. Okay, the last one, I will share the real application of PSO for solving the engineering problem. So the question is how to implement PSO for solving our optimization problem. Okay. Okay, so in this case, in this example, let's say we try to minimize the generation cost of microgrid. Okay, let's say we have a microgrid system. Okay, try to imagine we have let's say we have a generator 1, generator 2 from the fuel cell, for example. Okay, and then we have a wind turbine, and then we have a diesel generator. Okay, we have fuel cell, and this one is the diesel generator, for example. Okay, we try to determine what is the best power output for this generator. Okay, this power output become our variable. Okay, become our variable. We will try to determine what is the suitable, what is the best power output for generator 1, generator 2, generator 3, and so on. Okay, that's parameter that we want to determine by using optimization algorithm. Okay, so the next question is, what is our objective? Okay, we have to clearly define our objective. In this case, my problem variable actually 168, for example. Okay, for example, in this case, this is the real case, 168 variables. Okay, number 2, you have to determine what is the objective. What is your objective? Let's say our objective actually is to minimize the cost. So you have to formulate the cost function of your problem, of our problem. Okay, once we have a objective function and we determine the number of variables, of course we have a constraint. So you have to formulate your constraint. Okay, you have to formulate mathematically about your constraint. Sometimes you have a equality constraint. Okay, in some cases you have a inequality constraint. Okay, but in the most cases that I found in the optimization problem, they have a combination of equality constraint and equality constraint. Okay, once you determine the problem, the objective function, the variables, and the constraint, and then you can apply the optimization algorithm. Okay, for example, PSO. Okay, so the question is how to apply the PSO. Okay, in order to minimize, let's say, to minimize the cost of a microgrid system. For example, this is my personal experience. Okay, my real personal experience to minimize the cost of microgrid system. Okay, microgrid system. Okay, this is the real engineering problem, not the mathematical problem. Sometimes we try to show the example of mathematical problem with the simple concept, with the simple concept of the mathematical problem. But in this sharing, I try to show the real engineering problem. Maybe in your cases, maybe you can apply in your own real problem. Okay, this is the problem. Okay, objective function, and then you determine the number of variables. Sometimes we have 10 variables, and then you have to clearly define what is your constraint. Okay, the constraint actually is related to the variable, Okay, this is the flowchart of implementation of PSO algorithm for minimizing our objective function. Okay, first of all, we have to initialize the particles. We have to initialize the particles, the parameter of the PSO. In this case, we have to initialize the weight factor W, C1 and C2. Okay, we have to define the parameter of initial weight factor W, C1, C2, and population size. Okay, we need 4 parameters. Okay, for PSO, and then we need to evaluate the fitness function of each particles. Okay, we need to evaluate, and then for each iteration, we try to determine the best solution. Okay, for each particle, if the p-best is better than previous value, set the p-best as a current p-best. This one is This is the approach how to determine the p-best value, because we need to compare the p-best value of that particle to the previous best value. Okay, we need to quote this statement. Okay, and then set the p-best as g-best, and then update velocity and position of each particle according to the equation, according to the two equations that I have shown before. Let's say that's why I showed the real problem, because in the real problem we have a constraint. We have so many constraints. Of course, after we update the velocity and position of each particle, some particle or some possible solution basically is beyond the constraint. Okay, beyond our considered constraint. So the question is how to ensure that our solution is within the constraint. Of course, we need to introduce the constraint handling. So how to handle that constraint? Okay, after we handle that constraint, okay, we have several methods of constraint handling, and then you need to update the p-best and g-best. Okay, and then you repeat this process until the maximum iteration, for example, until the stopping criteria that you have set, for example, maximum iteration. We repeat the process until we get the optimal solution. For example, look at this figure. We have iteration 1, iteration 2 until iteration 500. Look at this blue line. Let's say we have set our population size is equal to 10. Okay, at iteration 1, this is the objective function. This is the value of objective function. Let's say 40,000. Okay, iteration number 2, they try to find the minimum solution and then PSO can get the minimum point, minimum objective function. Let's say 38,000. Iteration number 3, they try to minimize until the objective function is fixed. Okay, it's fixed up to our maximum iteration number that have been set in our algorithm. Okay, they try to minimize the minimum point. Okay, until the PSO cannot move to other solution. Okay, this is the example when we set the population size to 10. Let's say we try to set, is it 10 is the best population size for our problem? Because it depends to the nature of your problem. Okay, sometimes we feel this is not good, and then we try to increase the population size, let's say for 30. Okay, and then we can compare what is the behavior convergence characteristic for finding the minimum solution. So it shows that 30 is better than 10. Okay, and then we try to increase to 50. Is it we can find the best solution, and then we move to the 50. We set population size to 50, and then we see the convergence behavior of the algorithm. Okay, in some cases, when we increase the number of population size, the solution is fixed to the certain value. We cannot improve the solution, which means that population size is enough for your case study. If we increase more population size to our algorithm, of course it needs a lot of simulation time to complete the simulation to solve our problem. Okay, this is the convergence characteristic of the PSO for solving this problem. And then this is the important parameter that we need to look at if we implement optimization method. Okay, number one is optimization. Number one actually is convergence characteristic. How it shows the behavior of algorithm to find the minimum solution, for example. Okay, number two, we can evaluate the performance of algorithm according to the robustness. Robustness means you try to run you try to run the algorithm, let's say within 50 runs. What is the best result that can be obtained by different runs? Okay, the robust algorithm can give you the consistent result within the different runs. But in some cases, in some problem, especially in very complex problem, most of the algorithm cannot give the consistent result. Let's say, for example, you run at the first run, you get this, for example, we refer to population size equal to 70, the yellow one. Okay, the first run, you get this result. This is the objective function that you try to minimize. But the second run, you get this value. But the third run, you get the higher value. It's not consistent. Okay, the good algorithm can produce the consistent result. Okay, this is the due to the high complexity of the problem. In this case, we have we can say a quite high complexity of the problem because we have 160 variables. So the problem become very complex. So we can say most of the algorithm cannot produce the robust result, cannot produce the consistent result. But for the small variable, for the problem with the small variables, PSO can easily get the consistent result, okay, with different number of runs. Okay, that's the issue lah. That's related to the, maybe that related to the research. Okay, if you have the problem with the maybe 10 variable, PSO can work properly in terms of robustness. Okay, this is the example. Because we have 168 variables, so optimization algorithm must find the possible solution for each variable. Okay, variable 1, variable 2, variable 168. Okay, this is the variables that obtained that search or obtained by the PSO algorithm, and then this is the objective function. Okay, our purpose actually is to minimize the cost. Our objective actually is to minimize the cost. This is the value of the objective function obtained by the algorithm. Okay, I think this is the overview how to apply PSO algorithm in terms of concept. So the next question actually is how to code this algorithm into your programming software, for example, into the MATLAB. Okay, basically you can easily find the example of PSO in the maths work, for example, in the internet. Okay, and then once you understand the concept, you can easily use that coding from the maths work, for example, to solve your problem. Okay, you no need to code from, we can say from zero, because we have a lot of example in the internet or in the reliable source such as MathsWorks and so on. Okay, so what we can conclude from this sharing session, we can say that PSO has several advantages. Okay, number one, easy and simple to implement. Basically, PSO actually is easy and simple to implement compared to genetic algorithm, compared to artificial bee colony algorithm or ants colony algorithm. Okay, it's easy to implement. Okay, number two, have few parameters to tune. We have a population size, we have initial weight factor, C1 and C2, acceleration coefficient. We have around only 4 parameters that need to be tuned or adjust before we solve or we use that algorithm to solve our real problem. Okay. Number 3, less programming complexity compared to, for example, compared to genetic algorithm or compared to lightning search algorithm. Okay, I have experience implement lightning search algorithm to my engineering problem. I think LSA or lightning search algorithm is very complex. Okay, very complex in terms of programming, in terms of pseudocode and flowchart. So it's quite difficult to apply the lightning search algorithm to solve our real problem. Okay, okay. Number 4, fast convergence speed. Okay, fast convergence speed, and the most important thing actually is free derivative algorithm. When our algorithm is free derivative, there is no derivative method. Derivative method actually is dy dx. There is no dy dx. Okay, derivative of there is no derivative method that exists in the heuristic algorithm, so it can be used to solve any types of optimization problem, whether our problem is linear, non-linear, convex, or non-convex. Okay, but of course there is nothing perfect in the world. Okay, there is no single algorithm that can suit to all optimization problem in the world. Okay, there is no single solution, there is no single optimization method that can declare they are good in solving all the optimization algorithms in the world. Okay, there's nothing perfect. So what we can highlight that the disadvantages of PSO actually is it can be difficult to define the initial design parameter. Even they have 4 parameters, in some cases it's quite difficult to determine the suitable value for the PSO parameters. In some cases, in not all. Okay, it also can converge prematurely, which means that we try to find a global solution, but sometimes in some cases, especially in the complex optimization problem, they converge or they trap or into local solution. We call it converge prematurely. Okay, so which means that it's trapped at local solution, especially with the complex problem. Okay, especially with the complex problem. So therefore, we can see many improved, many hybrid, many enhanced version of PSO have been introduced by the researcher. Even if I can share with you, even in my PhD, I also implement PSO for solving my power system problem. Okay, I also introduce a new version of PSO. We call it modified particle swarm optimization with time varying acceleration coefficient. Okay, because when I implement the PSO, the original PSO to solve my engineering problem, I found that they have some problem. Okay, such as premature convergence, trap at local solution. So we try to think how to improve that algorithm. Okay, so in that case, I can get the idea. I got the idea to improve the original PSO to the enhanced PSO. Okay, we call it MPSO TVSC. Okay, for other researchers, they try to hybrid. They try to combine the PSO with other algorithm. For example, combine PSO with genetic algorithm, combine PSO with maybe Firefly algorithm. But the main purpose actually is to mitigate the problem of trap into local solution. Okay, or we can say a premature convergence. Okay, that's the advantages and disadvantages of the PSO. So lastly, this is the conclusion of my presentation. Okay, we almost finished 1 hour. Okay, this is the conclusion. The question is how to apply PSO algorithm. Okay, in this case, with the limited time, I didn't show how to code the algorithm, but I tried to share with you the concept of optimization and then the concept of PSO algorithm. So in order to apply the PSO algorithm, first of all, you need to define and formulate your optimization problem. You need to clearly define and formulate your optimization problem. Okay, consists of optimization function. What is the objective function? And then you have to know what is the variable that related to your objective function. Of course, this variable, they have their own constraint. You have to identify what is the constraint for that variables. Okay, so and then you can develop your own PSO algorithm. Okay, if you don't want to develop by your own, okay, from zero, maybe you can go to the MathsWorld and find the example of PSO algorithm, and then you can modify, try to suit with your application, with your optimization problem. Okay, I think that's all from me about introduction of particle swarm optimization. If you have any further discussion about PSO algorithm, how to implement, how to code, and so on. Maybe we can discuss through WhatsApp or email. Okay, this is my contact, this is my email. Okay, you can contact me. Inshallah, we can discuss, or maybe we can work together if we have any possibility to work together regarding the optimization method. Inshallah. Okay. I think that's all from me. I hope my a little bit knowledge or sharing experience in regarding the PSO can help you to enhance your project, to improve your project, to solve your optimization problem. Okay, I think that's all from me. Okay, thank you. Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, go back to our Mr. Moderator.
Okay, thank you very much for Dr. Mano. It's very interesting and inspiring presentation. So I do hope there's a question from the audience. So you may ask the question to the Dr. Mano if there is any question. Please, you can take this opportunity to ask.
Okay, Assalamualaikum Dr. Safiq Jamil from FSKTM.
Okay.
Thank you for a very interesting presentation. Okay, now I have one question. Actually, we are looking into this PSO as well, but our task is more on cloud forensic. Actually, one of my master students looking into this problem. Okay, my question is initial design parameter. This is the what we call it disadvantages of PSO. So, for example, in the forensic case for this cloud what do you call it, forensic for networking. So this initial design parameter, if you want to map it from for example a cloud based on this what they call bird movement, because they have a colony, have a group, right? And they have a leader. So how actually we want to map this kind of behavior?
Okay.
So they have a leader, right? So we must have a parameter where we have to map our actual problem with similar situation. So first is the population of the birds, and the second one is the leader. So the movement is based on the leader.
Okay. Okay. Basically, we try to merge the PSO principle of PSO and then the real problem. Basically, the leader actually is depending to our objective function.
All right. Okay.
Our objective function actually is to minimize.
Okay.
Minimize something. The minimum solution basically is become our leader.
Okay. Also, the minimum function is the leader of for this PSO.
Yeah, because in the PSO we have two important parameter. We have a personal best. Look at the previous equation. We have a personal best. This is the original PSO equation. We have a P best. We call it personal best. Personal best experience. This personal best experience actually is depending to our objective function. Okay, we have several number of population particles. Let's say for particle number 1, they have their best experience. Okay, for example, in the previous experience, the objective function, let's say, is 10. When they update, the objective function become 9. So the current position basically is become the best position for that particle. That situation we try to formulate in the programming.
Okay, I think that is the most difficult part, right?
Yeah, I know. I understand that the most difficult part actually is how to transfer from the pseudocode or flowchart of PSO to the real problem. But I think no worries. Basically, we have a lot of PSO example especially in the reliable source like Mathsword. I think can help us to put our PSO solving.
Okay, maybe later on we will have a discussion with Doctor after we completed the formulation and so on.
Inshallah, no problem.
Doctor advice on this matter. Thank you very much.
Okay, thank you, Dada.
Okay, Dr. Mano, there is another one question
Right.
from the participant. If the objective function is a multi-objective, how can we apply in PSO?
Okay, let's say if we have a multi-objective, okay, first of all, we have to clearly define the objective number one. For example, let's say in the objective number one, the parameter actually is to minimize the cost. Okay, for example. And number two, objective number two actually is to minimize the emission. In this situation, we have a different unit. This number one is cost. Let's say dollar per kilowatt hour, for example. And number two, let's say we have emission. Emission, of course, we have a number of ton of CO2 emission, number of kilogram. So of course we have a different unit. Okay, for solving multi-objective, we have a different approach. Number one, we can combine both objective become single objective by using weight sum method. Okay, that's the keywords weight sum method for multi-objective problems. Number one. And number two, we can solve this multi-objective function simultaneously by using multi-objective particle swarm optimization. That's another algorithm. We can say another algorithm because that multi-objective particle swarm optimization works differently with single objective. This one that I present today actually is single objective. For multi-objective, they have a different approach because we need to apply the crowding distance approach. The keyword actually is crowding distance approach for PSO. We have a different method to solve the multi-objective. Maybe I cannot answer exactly what you want because we need a lot approach. Okay, number one, you can combine both objective become single. In order to combine, we have several strategy to combine. We cannot directly F1 plus F2 because we have a different unit. We cannot add apple and orange. Okay, so we need some modification. A lot of literature discuss about this issue. Number one. Number two, we can use a multi-objective particle swarm optimization. Okay, in that algorithm, they try to modify the existing PSO by applying the crowding distance concept to determine the P-best because when we have a multi-objective problem, we can easily directly determine the P-best according to the existing approach. We need to apply the crowding distance to determine P-best, to determine G-best. The keyword actually is, if you are a research student, the keyword actually is crowding distance to determine P-best and G-best in the original PSO to become multi-objective algorithm.
Okay, I think this one there is another last question. What type or combination of PSO should be great on applying in optimizing data classification?
Okay.
Do meta-heuristic are good enough or use hybrid?
It's quite difficult to answer which one is good, but based on my experience, first of all, we try to use the original PSO and solve your problem. What do you feel with that solution? Is it okay or not for you? Sometimes that problem we don't know the solution. Okay, we don't know the optimal solution because that one is the real problem. No one solved that problem. You try to solve that problem. I think better you try to solve with the based on my personal experience, try to solve with the original PSO. Okay, what happened to the solution? Is it okay or not? If you're not satisfied with that algorithm, you can try to solve by using an improved version of PSO. Sometimes it can help you to solve your problem. But in some cases, even we apply the improved version of PSO because that improved version of PSO basically they test to another application. Of course, that application have their own complexity, which is not same with our application. But for general speaking, we can try to solve by using improved version of PSO. If you want to use the hybrid, maybe you can try with, I have a personal experience with PSO with ABC with artificial bee colony. I also have experience with PSO with Firefly algorithm. Based on my own application, I found that PSO Firefly algorithm works better than PSO ABC algorithm in my application. But if we read from the paper, they claim that PSO and ABC is better compared to PSO and Firefly algorithm. But to get the real result, I think better we try to test. We try to test to our problem, because the nature of problem basically is different. That's my personal opinion. I cannot give the answer which one is better. But if you read from the literature, sometimes they claim they are better. But if we try, we can know which one that one is better or not for our application. Because in the optimization problem, there is no single method that's suit to all optimization problem. But it can be used as a guideline for us to try. Okay.
Okay, all right. So I think thank you very much for Dr. Mano for the nice sharing, and thank you again for all the participants who already follow this talk. So I think